Language Integrated Query is a Microsoft .NET Framework component that adds native data querying capabilities to .NET languages, although ports exist for Java, PHP, JavaScript and ActionScript. LINQ extends the language by the addition of query expressions, which are akin to SQL statements, and can be used to conveniently extract and process data from arrays, enumerable classes, XML documents, relational databases, and third-party data sources. Other uses, which utilize query expressions as a general framework for readably composing arbitrary computations, include the construction of event handlers or monadic parsers. LINQ also defines a set of method names, along with translation rules used by the compiler to translate Fluent-style query expressions into expressions using these method names, lambda expressions and anonymous types. Many of the concepts that LINQ has introduced were originally tested in Microsoft's Cypermail research project. LINQ was released as a major part of .NET Framework 3.5 on November 19, 2007. Architecture of LINQ in the .NET Framework, standard query operators. In what follows, the descriptions of the operators are based on the application of working with collections. Many of the operators take other functions as arguments. These functions may be supplied in the form of a named method or anonymous function. The set of query operators defined by LINQ is exposed to the user as the standard query operator API. The query operators supported by the API are: select. The select operator performs a projection on the collection to select interesting aspects of the elements. The user supplies an arbitrary function, in the form of a named or lambda expression, which projects the data members. The function is passed to the operator as a delegate. Where. The where operator allows the definition of a set of predicate rules that are evaluated for each object in the collection, while objects that do not match the rule are filtered away. The predicate is supplied to the operator as a delegate. Select many. For a user-provided mapping from collection elements to collections, semantically two steps are performed. First, every element is mapped to its corresponding collection. Second, the result of the first step is flattened by one level. Note: select and where are both implementable in terms of select many, as long as singleton and empty collections are available. The translation rules mentioned above still make it mandatory for a LINQ provider to provide the other two operators. Sum/min/max/average, these operators optionally take a function that retrieves a certain numeric value from each element in the collection and uses it to find the sum, minimum, maximum or average values of all the elements in the collection, respectively. Overloaded versions take no function and act as if the identity is given as the lambda. Aggregate. A generalized sum/min/max. This operator takes a function that specifies how two values are combined to form an intermediate or the final result. Optionally, a starting value can be supplied, enabling the result type of the aggregation to be arbitrary. Furthermore, a finalization function, taking the aggregation result to yet another value, can be supplied. Join/group join. The join operator performs an inner join on two collections, based on matching keys for objects in each collection. It takes two functions as delegates, one for each collection, that it executes on each object in the collection to extract the key from the object. It also takes another delegate in which the user specifies which data elements, from the two matched elements, should be used to create the resultant object. The group join operator performs a group join. Like the select operator, the results of a join are instantiations of a different class, with all the data members of both the types of the source objects, or a subset of them. Take/take while, the take operator selects the first n objects from a collection, while the take while operator, which takes a predicate, selects those objects that match the predicate. Skip/skip while, the skip and skip while operators are complements of take and take while. They skip the first n objects from a collection, or those objects that match a predicate. Of type, the of type operator is used to select the elements of a certain type. Concat, the concat operator concatenates two collections. Order by/then by, The order by operator is used to specify the primary sort ordering of the elements in a collection according to some key. The default ordering is in ascending order. To reverse the order by descending operator is to be used. Then by descending specifies subsequent ordering of the elements. The function to extract the key value from the object is specified by the user as a delegate. Reverse. The reverse operator reverses a collection. Group by. The group by operator takes a function that extracts a key value and returns a collection of I-grouping key values objects for each distinct key value. The I-grouping objects can then be used to enumerate all the objects for a particular key value. Distinct. The distinct operator removes duplicate instances of an object from a collection. An overload of the operator takes an equality compare object which defines the criteria for distinctness. Union/intersect/except, these operators are used to perform a union, intersection and difference operation on two sequences, respectively. Each has an overload which takes an equality compare object which defines the criteria for element equality. Sequence equal. The sequence equal operator determines whether all elements in two collections are equal and in the same order. First/first or default/last/last or default. These operators take a predicate. The first operator returns the first element for which the predicate yields true, or, if nothing matches, throws an exception. The first or default operator is like the first operator except that it returns the default value for the element type in case nothing matches the predicate. The last operator retrieves the last element to match the predicate, or throws an exception in case nothing matches. The last or default returns the default element value if nothing matches. Single. The single operator takes a predicate and returns the element that matches the predicate. An exception is thrown, if none or more than one element match the predicate. Single or default. The single or default operator takes a predicate and returns the element that matches the predicate. If more than one element matches the predicate, an exception is thrown. If no element matches the predicate, a default value is returned. Element at. The element at operator retrieves the element at a given index in the collection. Any/or. The any operator checks if there are any elements in the collection matching the predicate. It does not select the element, but returns true if at least one element is matched. An invocation of any without a predicate returns true if the collection non-empty. The all operator returns true if all elements match the predicate. Contains. The contains operator checks if the collection contains a given element. Count. The count operator counts the number of elements in the given collection. An overload taking a predicate counts the number of elements matching the predicate. The standard query operator API also specifies certain operators that convert a collection into another type, as enumerable statically types the collection as an enumerable T. As queryable, statically types the collection as an queryable T. To array, creates an array T from the collection. To list, creates a list T, from the collection. To dictionary, creates a dictionary K, T, from the collection, indexed by the key K. A user-supplied projection function extracts a key from each element. To lookup, creates a lookup K, T, from the collection, indexed by the key K. A user-supplied projection function extracts a key from each element. Cast, converts a non-generic enumerable collection to one of enumerable T. By casting each element to type T. Alternately converts a generic enumerable T, to another generic enumerable R. By casting each element from type T to type R. Throws an exception in any element cannot be cast to the indicated type. Of type, converts a non-generic enumerable collection to one of enumerable T. Alternately converts a generic enumerable T, to another generic enumerable R. By attempting to cast each element from type T to type R. In both cases, only the subset of elements successfully cast to the target type are included. No exceptions are thrown. Language extensions. While LINQ is primarily implemented as a library for .NET Framework 3.5, it also defines optional language extensions that make queries a first-class language construct and provide syntactic sugar for writing queries. These language extensions have initially been implemented in C 3.0, VB 9.0, F and Oxygen, with other languages like ML having announced preliminary support. The language extensions include query syntax. A language is free to choose a query syntax that it will recognize natively. These language keywords must be translated by the compiler to appropriate LINQ method calls. Implicitly typed variables. This enhancement allows variables to be declared without specifying their types. The languages C 3.0 and Oxygen declare them with the var keyword. In VB 9.0, the dim keyword without type declaration accomplishes the same. Such objects are still strongly typed. For these objects, the compiler infers the types of variables via type inference, which allows the results of the queries to be specified and defined without declaring the type of the intermediate variables. Anonymous types. Anonymous types allow classes that contain only data member declarations to be inferred by the compiler. This is useful for the select and join operators, whose result types may differ from the types of the original objects. The compiler uses type inference to determine the fields contained in the classes and generates accessors and mutators for these fields. Object initializer. Object initializers allow an object to be created and initialized in a single scope, as required for select and join operators. Lambda expressions. Lambda expressions allow predicates and other projection functions to be written in line with a concise syntax, and support full lexical closure. They are captured into parameters as delegates or expression trees depending on the query provider. For example, in the query to select all the objects in a collection with some property less than 10. The types of variables result, C and results all are inferred by the compiler in accordance to the signatures of the methods eventually used. The basis for choosing the methods is formed by the query expression free translation result. LINQ providers. The C 3.0 specification defines a query expression pattern along with translation rules from a LINQ expression to an expression in a subset of C 3.0 without LINQ expressions. The translation thus defined is actually untyped, which, in addition to lambda expressions being interpretable as either delegates or expression trees, allows for a great degree of flexibility for libraries wishing to expose parts of their interface as LINQ expression clauses. For example, LINQ to objects works on enumerable T/S and with delegates, whereas LINQ to SQL makes use of the expression trees. The expression trees are at the core of the LINQ extensibility mechanism, by which LINQ can be adapted for many data sources. The expression trees are handed over to LINQ providers, which are data source-specific implementations that adapt the LINQ queries to be used with a data source. If they choose so, the LINQ providers analyze the expression trees contained in a query in order to generate essential pieces needed for the execution of a query. This can be SQL fragments or any other completely different representation of code as further manipulatable data. LINQ comes with LINQ providers for in-memory object collections, Microsoft SQL Server databases, ADO.NET datasets and XML documents. These different providers define the different flavors of LINQ. LINQ to objects. The LINQ to objects provider is used for in-memory collections, using the local query execution engine of LINQ. The code generated by this provider refers to the implementation of the standard query operators as defined on the sequence pattern and allows enumerable T collections to be queried locally. Current implementation of LINQ to objects perform interface implementation checks to allow for fast membership tests, counts, and indexed lookup operations when they are supported by the runtime type of the enumerable. LINQ to XML. The LINQ to XML provider converts an XML document to a collection of Xelement objects, which are then queried against using the local execution engine that is provided as a part of the implementation of the standard query operator. LINQ to SQL. The LINQ to SQL provider allows LINQ to be used to query Microsoft SQL Server databases, including SQL Server Compact databases. Since SQL Server data may reside on a remote server, And because SQL Server has its own query engine, LINQ to SQL does not use the query engine of LINQ. Instead, it converts a LINQ query to a SQL query that is then sent to SQL Server for processing. However, since SQL Server stores the data as relational data and LINQ works with data encapsulated in objects, the two representations must be mapped to one another. For this reason, LINQ to SQL also defines a mapping framework. The mapping is done by defining classes that correspond to the tables in the database, and containing all or a subset of the columns in the table as data members. The correspondence, along with other relational model attributes such as primary keys, are specified using LINQ to SQL defined attributes. For example, this class definition maps to a table named customers and the two data members correspond to two columns. The classes must be defined before LINQ to SQL can be used. Visual Studio 2008 includes a mapping designer that can be used to create the mapping between the data schemas in the object as well as the relational domain. It can automatically create the corresponding classes from a database schema, as well as allow manual editing to create a different view by using only a subset of the tables or columns in a table. The mapping is implemented by the data context that takes a connection string to the server, and can be used to generate a table T, where T is the type to which the database table will be mapped. The table T encapsulates the data in the table, and implements the enumerable T interface, so that the expression tree is created, which the LINQ to SQL provider handles. It converts the query into TSQL and retrieves the result set from the database server. Since the processing happens at the database server, local methods, which are not defined as a part of the Lambda expressions representing the predicates, cannot be used. However, it can use the stored procedures on the server. Any changes to the result set are tracked and can be submitted back to the database server. LINQ to datasets. The LINQ to SQL provider works only with Microsoft SQL Server databases. To support any generic database, LINQ also includes the LINQ to datasets, which uses ADO.NET to handle the communication with the database. Once the data is in ADO.NET datasets, LINQ to datasets execute queries against these datasets. Performance. Users may struggle with subtleties in the LINQ to objects features and syntax. Suboptimal LINQ implementation patterns can lead to a serious degradation of performance. LINQ to XML and LINQ to SQL performance compared to ADO.NET depends on the use case. PLINQ, version 4 of the .NET framework includes PLINQ, or parallel LINQ, a parallel execution engine for LINQ queries. It defines the parallel query T class. Any implementation of the enumerable T interface can take advantage of the PLINQ engine by calling the parallel-T, this enumerable T, extension method defined by the parallel enumerable class in the system LINQ namespace of the .NET framework. The PLINQ engine can execute parts of a query concurrently on multiple threads, providing faster results. Implementations in other languages. Java. Saffron is an extension to Java incorporating SQL-like relational expressions. Relations can be in-memory collections, database tables, or other data sources. It was developed independently of LINQ in 2001 by Julian Hyde, who later authored the Mondrian OLAP server. Query is a Java implementation of LINQ. JAK is a type-safe Java implementation of LINQ. JAK Java implementation of LINQ. JUGA Java implementation of LINQ. JINQ is an open-source implementation of LINQ-style queries for Java. It extends the Java 8 Streams API and sits on top of JPA. It uses a bytecode analysis framework based on symbolic execution. Queryxl is a type-safe Java implementation of LINQ. SBQL4J is a Java extension with capabilities of LINQ, based on stack-based approach. It provides type-safe queries to Java with powerful engine. JavaScript. JLINQ is a fully extensible JavaScript library that allows you to perform LINQ-style queries on arrays of object. JLINK Node is a fork of JLINQ, ported to a Node.js module by Nick Martin. An NPM package also available. JSINQ is currency's JavaScript implementation of LINQ to objects. Also provides a compiler that translates LINQ-style query expressions into JavaScript code. JSLINQ is yet another JavaScript library that allows you to perform LINQ-style queries on data. Chris Pietschmann's LINQ to JavaScript is a LINQ implementation that extends JavaScript's array object with LINQ capabilities. LINQ.js LINQ for JavaScript. ActionScript 3. ActionLINQ is a LINQ to objects implementation by Brian Genesio. FINQ is another LINQ to objects implementation by readably. PHP, FINQ is Tommy Montgomery's PHP implementation of LINQ. FPLINQ is Martin Belial's PHP implementation of LINQ. Others, ASQ is a Python implementation of LINQ to objects and parallel LINQ to objects. Embarcadero Prism, also known as Delphi Prism, supports LINQ. LINQ is a LINQ-like library for a minimal subset of the Lua scripting language. HXLINQ is a Higgs port of Chris Pietschmann's LINQ to JavaScript. See also, Object Relational Mapping, Object Relational Impedance Mismatch, List Comprehension, Lazy Evaluation, References. External links. Official Microsoft LINQ project, 101 C LINQ samples, 101 Visual Basic LINQ samples, F3.0 LINQ samples, LINQ to XML documentation, Microsoft LINQ forum, LINQ to objects for the .NET developer, LINQ page on netfxguide.com, LINQ wiki, LINQ books, continuous LINQ, LINQ to SharePoint, LINQ to Active Directory, LINQ for Novel Directory LDAP, link to Wikipedia, LINQ tutorials and active articles, looking to LINQ, will Microsoft's language integrated query transform programmatic data access? Optics, LINQ to SNMP, future of LINQ to SQL, LINQ exchange, learn LINQ and Lambda expressions, more link. Extensions to LINQ to objects by John Skeet, 50 LINQ examples, tips and how-tos, how does it work in C? Part 3, a complete LINQ tutorial series, LINQPad, LINQ query sandbox utility, adaptive link, adding the notion of cube in an LINQ query.